You have thrown away a plant that was still alive. I know you have. Most people have. It looked too far gone. The leaves were yellow, the stems were soft, the soil smelled wrong, and you made the call that every gardener eventually makes. You gave up on it. And here is what nobody told you. Most of those plants were not dead. They were waiting, sitting in the wrong conditions, in soil that had stopped working, with roots that had nothing left to breathe, waiting for one decision that changed everything. Today I am going to show you exactly how to bring a plant back from the edge. The method. The one thing most gardeners have never considered, and the single mistake that kills more recovering plants than anything else. Stay with me through this entire video, because the last step is the one that determines whether everything before it works or fails completely. Before we go further, drop your state in the comments right now. Because what kills plants in Houston is not what kills them in Chicago, and I want to know where you are gardening. Drop it below. I read everyone. Why plants reach this point. A struggling plant is almost never the result of one thing going wrong. It is a sequence. It starts with soil that has been in the same pot too long. Soil compacts over time. The air pockets that healthy roots depend on collapse. Water starts moving through unevenly, pooling in some areas, bypassing others completely. The root zone loses oxygen. Roots in low oxygen conditions cannot absorb nutrients. They cannot repair damaged tissue. They slow down, weaken, and become vulnerable to the bacterial and fungal activity that thrives in exactly those conditions. Then the visible symptoms appear. Yellow leaves, soft stems, dropping foliage, and the gardener sees the symptoms and treats the symptoms. New fertilizer, more water, less water, a different location. None of it works because none of it addresses what is actually wrong. The problem is underground. The solution has to start there too. This is what most gardening advice misses completely. You cannot fix a plant from the top down. You fix it from the roots up. And once you understand that, the entire approach to plant recovery changes. Step 1. Remove everything the roots are fighting against. The first step is complete soil removal, not a partial refresh, not loosening the top layer, not a light rinse. Everything comes off the root system, every trace of old soil. And I want to be specific about why this is not optional for a plant in serious decline. Old soil on a struggling root system is not neutral. It is carrying the bacterial and fungal populations that caused or accelerated the problem. It is compacted in ways that restrict oxygen even after repotting. It holds moisture unevenly. Leaving it on the roots and simply adding fresh soil around it is like changing the water in a fish tank without cleaning the glass. The environment looks different. The underlying problem continues. When you remove all the old soil, you see exactly what you are working with. And what you find will tell you everything about the plant's actual condition. Firm, white or cream-colored roots with good structure mean strong recovery potential. Soft, brown, or black roots mean rot has set in, and those sections need to be removed cleanly with a sterile blade before anything else happens. Thin, pale, underdeveloped roots with no obvious rot mean a plant that has been struggling for a long time, but has not crossed the point of no return. That last category is the one most people give up on too soon. Thin and pale is not dead. Thin and pale is depleted. And a depleted root system responds remarkably well to the right intervention. Step 2. The one thing most gardeners never use. Plain water is not enough for a root system in serious decline. This is where I want to slow down completely and explain something that most gardening content never covers, because it is one of the most consistently effective tools in plant recovery, and almost nobody uses it. Hydrogen peroxide. Standard 3% hydrogen peroxide. The same bottle that costs under $2 at any pharmacy or grocery store in America. 1 teaspoon per 1.5 liters of room temperature water. That is the complete formula. Nothing else. Here is the biology. When hydrogen peroxide contacts water, it releases a single free oxygen atom. That oxygen floods the root zone with the one thing severely compromised roots are most deprived of: oxygen. Healthy, well-structured soil is full of microscopic air pockets that keep roots oxygenated constantly. Compacted, waterlogged, or exhausted soil has almost none. Roots in oxygen-depleted conditions cannot absorb nutrients. They cannot generate new growth. They cannot fight off the pathogens that thrive in that same depleted environment. The hydrogen peroxide solution addresses all three problems simultaneously. It delivers oxygen directly to the root zone. It creates conditions that are hostile to the anaerobic bacteria responsible for root rot. And it does this without leaving any chemical residue that builds up in the soil over time. It breaks down completely into water and oxygen. Nothing harmful remains. Room temperature water is not a minor detail. Cold water shocks already stressed root tissue and slows the biological processes you are trying to accelerate. Hot water causes direct cellular damage. Room temperature is the one variable that works entirely in the plant's favor, with nothing working against it. Place the cleaned root system into the solution and leave it for 30 minutes. Not an hour. Not overnight. 30 minutes. You are giving the roots a targeted oxygen treatment, not a prolonged soak. The goal is stimulation, not saturation. Step 3. What to do with the top growth. While the roots are soaking, I want to address something that comes up constantly when people are working with a struggling plant. The impulse to take cuttings, to salvage something from the top growth while the root system recovers, to try to propagate before the original plant is stable. Do not do this. And I want to explain exactly why, because understanding it will save you cuttings and frustration on every recovery you attempt going forward. A plant under serious stress is directing every available resource toward its own survival. There is no surplus to allocate. A cutting taken from that plant carries the same stress into whatever medium you place it in. It does not have the energy reserves to initiate root development. The cells that would normally differentiate into root tissue are already consumed by the effort of staying alive. The cutting does not root. It deteriorates. This is not a failure of technique. It is biology working correctly. The plant made the right decision with the resources it had. The mistake was asking it to do two things at once when it barely had enough for one. Wait until recovery is confirmed. Wait until you see new leaves pushing from the stems. Wait until the root system has rebuilt enough structure to support active growth above the soil line. That is your propagation window. Before it, cuttings are unlikely to root, and you lose material the plant needed. Step 4. The right container and the right mix. After the soak, the root system goes into its recovery container, and every decision here matters in ways that most repotting guides never fully explain. Container size first. Choose a pot that fits the current root system with a small amount of room to expand, not a large container with significant excess soil volume around the roots. This is one of the most consistent mistakes made when repotting a struggling plant. The logic seems sound. Give it more room to grow. But what actually happens is that the large volume of excess soil surrounding the weak root system stays wet for extended periods, because those roots are not yet drawing moisture from it. That standing moisture creates the same oxygen-depleted, pathogen-friendly conditions that caused the problem originally. You have changed the pot and recreated the problem. Fit the container to the roots. Upsize when the plant is actively growing and filling the current pot. Drainage is non-negotiable. The container needs drainage holes that actually function. Water should move through the soil and exit the drainage holes within seconds of application. If it pools on the surface or drains slowly, the soil mix is too dense and it needs to be corrected before planting. The soil mix that works best for recovery combines a quality peat-based universal potting mix with perlite at roughly a 30% ratio by volume. The perlite keeps the mix structurally open. It maintains air pockets around the roots regardless of how frequently or infrequently you water. It prevents the compaction that started this problem in the first place. This is not a premium or complicated mix. It is available everywhere, and it costs almost nothing. But it does the one thing that matters most for a compromised root system. It keeps oxygen in the root zone. A shallow layer of expanded clay or coarse gravel at the base of the container adds additional drainage insurance. If you do not have it, skip it. The perlite in the mix is doing the essential structural work. Do not delay the repot waiting for a material you do not need. One detail that causes more failed recoveries than almost anything else. The stem base. The transition point where stem meets roots needs to sit at or just above the soil surface after planting. Burying it even slightly creates conditions for stem rot to develop in the weeks immediately following repotting. By the time symptoms appear above the soil line, the damage underneath is already advanced. Leave that transition point visible. Do not cover it. The first watering after repotting, the first watering this plant receives in its new container, is hydrogen peroxide solution again. 1 teaspoon per liter of room temperature water. Same formula, slightly more diluted. The repotting process, even a careful one, is a stress event. Roots were disturbed. The soil environment changed completely. The hydrogen peroxide solution gives the root zone an immediate oxygen boost and neutralizes any bacterial transfer that occurred during handling. After this first watering, stop. Step back. Do not water again until the top layer of soil is dry to the touch at finger depth. Not slightly dry, Dry. Press your finger into the soil to the first knuckle. If it feels dry at that depth, water thoroughly until it drains freely from the bottom of the container. Then wait again. That rhythm, thorough watering followed by waiting for genuine dryness, is what allows recovering roots to breathe between waterings, rebuild their structure, and extend into the new soil without sitting in moisture that will set the whole process back. The instinct to water frequently because the plant looks stressed is the instinct that kills more recovering plants than anything else in this entire process. A stressed plant that is also sitting in wet soil is fighting two problems instead of recovering from one. What recovery actually looks like. Recovery is not dramatic. It does not happen in days. The first visible sign is usually a single new leaf, small, slightly pale, pushing from a stem that looked finished weeks ago. That leaf is confirmation that the root system has rebuilt enough function to support above-ground growth again. It is not decorative, it is data. It tells you the approach worked, and the plant is no longer surviving. It is growing. After that first leaf, more follow. The pace increases. The new growth comes in stronger and more vigorous than the leaves the plant had before the intervention. The root system that rebuilt itself in the right soil, with adequate oxygen, watered correctly, is now a stronger foundation than the one you started with. This entire process from intervention to confirmed recovery typically takes 4 to 6 weeks. Some plants respond faster, some take longer. The variables are the severity of the original decline, the temperature and light conditions during recovery, and how consistently the watering rhythm is maintained. What does not vary is the principle. Oxygen to the roots, correct soil structure, correct container size, correct watering. Those 4 things, applied consistently, give a struggling plant everything it needs to come back. Everything else is secondary. The plant on your windowsill right now. Here is what I want you to take from this video. The specific plant does not matter as much as the principles do. The hydrogen peroxide treatment works for any houseplant with a compromised root system. Oxygen deprivation in the root zone is not species-specific. The soil principles apply universally. The container sizing logic applies universally. The watering rhythm applies universally. Right now, somewhere in your home, there is a plant you have already written off. A plant sitting in a corner because you are not sure what to do with it. A plant you are about to replace at the next garden center trip. Before you do that, look at the roots. Clean them. Treat the root zone with hydrogen peroxide solution. Put it in the right-sized container with the right mix. Water correctly. Leave it alone. It may surprise you the same way a plant like this surprises most people who try this approach for the first time. The plant was not the problem. The environment was the problem. Change the environment and the plant does the rest. Drop a comment below and tell me what plant you are trying to save right now. Tell me what state you are in and what the symptoms look like. I read every comment and your answers directly shape the next video. If this gave you one thing you are going to use this week, subscribe right now. This channel releases practical, experience-based plant content every single week. Real techniques, real results, no filler. The next video is just as useful as this one. Hit subscribe and make sure it finds you.